Current electricity. It is the branch of physics which deals about the charge particle in motion and its effect. Current flow of anything constitutes current of that thing. For example, flow of water current, flow of heat current, flow of charge, electric current. Here we use the term current for electric current. Now electric current. It is the net charge flowing per second through any cross section area of a conductor. Electric current, total charge flown divided by total time taken. Here it is a cross section part of any conductor is shown and charge is flowing through. Positive charge as well as negative charge is flowing. So net charge will be I equals to Q plus minus of Q minus by T, because only we considered flow of positive charge. So equals to Q by T. There Q by T is the net current flown through the cross section in time T interval. Again here I equals to can be written as I Q plus Q minus by T with sign. We have to use sign in the when we put the value, or I equal to mode of plus Q minus of mode of Q minus by T. If we have to take only magnitude value, then we can use this formula, where Q plus is magnitude of total positive charge flown in one direction in time interval T, and Q minus is the magnitude of total negative charge flown in the same direction. Q equals to net charge flown in time T. Practically possible system. Here some system are shown where charge is flowing. For example, it is a conductor. So here in conductor electrons flow, and in conductor if electron direction is in this direction, then current direction will be in this direction. That is, in conductor current is always opposite to the direction of electron movement. Here a semiconductor is shown. In semiconductor, current is due to both electron flow and hole flow. For example, hole is flowing in this direction and electron is flowing in this direction. So net charge will be because both are in flowing current due to electron in this direction and current due to hole is this direction. So I will be I plus I minus. Here positive discharge tube in which positive ion and electron is flowing. The positive ion is flowing in this direction and electron is flowing in this direction. So net current due to electron will be in this direction. So I will be total current will be due to current due to positive ion plus current due to electron. Again here a voltmeter is shown, that it is in a solution electrolytes. Positive ion is flowing in this direction. This is cathode and anode. To positive direction is flowing in this direction, and electron is flowing in this direction. Again here current will be constituted by the two currents, one from the positive ion, flow of positive ion, and another due to flow of electron, because electron is flowing in this direction, so current will be in this direction due to electron. So these are the some examples of flow of current and positive and negative charge. Now we will study the direction of current. 1. Direction of current is in the direction of flow of positive charge, or opposite the direction of flow of negative charge. We have to take this convention. That is, we have to choose the direction in this direction in which positive charge is flowing and opposite to the flow of negative charge. Now average current. Average current is defined as I average equal to delta Q by delta T, or Q by T, where delta Q is the charge flown in time interval delta T, and instantaneous current, that is current at particular instant. It is given as I equals to limit delta T tends to 0, delta Q by delta T equals to dq by dt. Unit of current I, because we have I equal to q by t, and unit of q is coulomb and it is second, so coulomb per second called ampere. Dimension, if current is fundamental quantity, then dimension of I will be a, because in SI unit it is considered as fundamental quantity, so in SI unit this will be the dimension. Second, if charge is fundamental quantity, in MSKQ, MSK, MKSQ system, charge is considered as fundamental quantity, so I will be q by t. So dimension of I, dimension of q by dimension of t equal to qt minus 1. Definition of ampere, that is 1 coulomb of charge flowing per second through any cross section of the conductor is called 1 ampere. We have I equal to dq by dt, this implies dq equals to I dt, hence q will be integration dq integration I dt, net charge flow. A current of 2.5 into 10 to the power minus 2 ampere is flowing through a metallic wire for 4 minutes. How many electrons are passing through any cross section? Because we have I equal to q by t, or q equal to I into t, and now we know that q is equal to n into e, where e is the electronic charge, equals to it, hence n will be it by e. Putting the value, given the value of current in SI unit 2.5 into 10 to the power minus 2 ampere into 4 into 60 second, 4 minutes is equal to 4 into 60 second divided by E equal to 1.6 magnitude of E, 1.6 into 10 to the power 19 coulomb equals to 3.75 into 10 to the power 19 electrons are crossing a cross section of conductor per second. It means this number of electrons is crossing the conductor cross section per second. Next, the current flowing through a metallic wire varies with time as I equals to 10 into t plus 4, where I is in ampere and t is in second. What is the amount of charge passing through wire between the time interval t equal to 2 seconds to t equal to 4 seconds? Here again we can solve I equal to dq by dt, dq equal to I dt, hence q equals to integration of dq integration of and we are given time interval, we have to take time interval as 2 seconds to t equals to 4 seconds. So in the limit we have to put 2 and 4 and 10t plus 4 into dt. Now integrate this, the value of integration will integration 2 to 4 tt dt integration 2 to 4 4 dt equals to 10 into, because 10 is constant, so it comes out of the integration, and t dt equals to t square by 2, 2 to 4, similarly 4 into t, 2 to 4, and solving this, t by 2 under bracket 4 square minus 2 square, 4 into under bracket 4 minus 2, or 5 into 16 minus 4 plus 4 into 2 equals to 5 into 12 plus 8, 68 coulomb. So charge flown in this time interval is 68 coulomb through any cross section of that conductor. Electric current in conductors. In conductors, electrons are in random motion when it is independently placed, that is, it is not potential difference is not applied to their end of the conductor, then also electrons are in random motion, so number of electrons crossing any cross section in this side is equal to this side, so net crossing of electron is 0 at any time, and velocity which it moves in randomly in this conductor is Vrms is given by 3 root under 3 kt by m, and putting this value we get 3 into the k value is 1.38 10 to the power minus 28, and temperature is room temperature is 300, so 3 and mass of electron is 9.1 into 10 to the power minus 30, about 10 to the power 5 meter per second, that is electrons randomly moves in the conductor with this velocity, and because total number of electrons crossing one side is equal to the other side, so net current in a conductor when it was not under the electric field or a potential difference is zero, so no current flows in a conductor, and it is considered as electron gas, which are a huge amount of electrons, free electrons are available for movement in the conductor, so it is considered as electron gas. Electron gas moving in random direction, so number of electron crossing any cross section is zero. There it is shown. For example, if consider electron is flowing in this direction, one electron is, and another is flowing in this direction. So for this electron current will be in this direction, and for this electron current will be in this direction. So I net will be I minus I equal to 0. So this formula is applied for whole current in the conductor. Now, when we apply a potential difference to the end of a conductor, a electric field is set up in the conductor, and electrons start to drift in only one direction. So there is a net drifting of electrons in only one direction. So we get due to this drifting, we have a current flow in the conductor. Here charge discs are placed in outside the end of conductor, and due to this electric field is set up in the conductor, and electrons start to drift, and the drift velocity is speed is about 10 to the power minus 4 meter per second. So this is the difference, because if we compare VRMS speed, your average speed of electron with drift speed, then there is a huge difference between these two, because it has 10 to the power 5 meter per second random movement, and drifting of electron is only about 10 to the power minus 4 meter per second, very slow. Charged metallic disc creates electric field in between the ends. To maintain constant electric field, a cell is used or a battery is used. Now some important point regarding the current. Current is a scalar quantity. The direction only represents the sense of flow of charge. So if consider there is a two conductor, one is adjoined with a third conductor, and in first conductor I1 current is flowing, and second conductor I2 current is flowing. Then in third conductor I current will be equal to the I1 plus I2, because it is a scalar quantity, so we have to get net current by adding up only. We will not apply vector addition, and this direction only show the flow of charge, not the it represents that current is a vector, because it does not follow the vector law of addition. Second, for a given conductor, current does not change with change in cross section. This is a very important point. If same conductor with different cross section is given, and current, if we set up a current, then if we consider that I1 current is flowing in this cross section, and I2 is this cross section, and I3 is this cross section, so according to this concept, I1, I2 and I3 will be equal to, every current is equal to each other. That is, it does not depend upon the cross section of conductor. Now current. Current are there are two types of current. One is direct current and another is alternating current. And in this direct current, that is direction and magnitude of current is constant. For example, it is shown with the graph, because value of current is constant and flowing with same rate. And in alternating current direction and magnitude of current change periodically. That is always change its value and as well as direction change. If one time it is flowing in this direction, then after some time it will flow in this direction, again in this direction. So it show a periodic motion or selective, not oscillatory, only periodic motion we can say. Only they change their direction. And this is called AC current and this is called DC current. Here it is shown that here we see that I is fixed with respect to time, but here I is not fixed. Value of I is changing with respect to time, and also direction is changing. Next topic, current due to rotating motion of a charge. Consider if a point charge Q is moving in a circle of radius r with a speed v, then its time period t equals to 2 pi r by v. So through a cross section perpendicular to the motion, it will pass 1 by t times per second, that is f equal to 1 by t into v by 2 pi r. And as the particle has charge q, so I will be I q by t, so q into f. This is equal, because as the particle has charge q, so hence I equals to q by t, q into f, or tv by 2 pi r, or v by 2 pi r, v by r is omega, so q omega by 2 pi. This will be the value of current in a if current is in circular motion, charge is in circular motion, so this formula will be given. In the Bohr model of hydrogen atom, the electron is pictured to rotate in a circular orbit of radius 5 into 10 to the power minus 11 meter. Rotate, or here it should be each word should be revolve. 5 into 10 to the power minus 11 meter at a speed of 2.2 into 10 to the power 6 meter per second. What is the current associated with electron motion? We have formula for I equal to qv by 2 pi r. So, and here charge value is E, electronic charge, E into V by 2 pi r, and all value is given. Electrons value is 1.6 into 10 to the power 19 coulomb, and velocity is given 2.2 into 10 to the power 6 meter per second, linear speed, and 2 and the pi value 3.14 into radius is given 5 into 10 to the power 11 meter, and solving we get 1.12 milliampere of current due to that electron revolution. Next question. Gopal. The surface charge density of a disk of radius r is given by sigma equal to sigma naught x square, where sigma naught is a constant and x is the distance measured from the center. The disk rotates with an angular velocity omega naught about an axis passing through its center. Find the current constituted. Here, because disk is rotating, so every part of current in that disk is revolving in a circular motion, and so every current will constitute a current. So we have to find that current due to whole disk. So for it, consider a circular strip of thickness dx at a distance x from center. Area of a strip dA equal to 2 pi x into dx. Area of this strip will be 2 pi x into dx. Hence, charge on a strip dq equal to sigma dA, because surface charge density is given. This surface charge density of sigma equal to sigma naught. Now value of sigma is given here, sigma naught x square. So putting this value equals to sigma naught x square 2 pi x dx, 2 pi sigma naught x cube dx. Hence elementary current constituted by rotation of a strip di equals to dq omega naught by 2 pi and equals to, we know that q omega naught by 2 pi formula. So here elementary charge will flow. So dq we have taken dq omega naught by 2 pi, or putting the value of dq, this value is dq. So omega naught to pi sigma naught x cube by dx by 2 pi, because we have I equal to q omega by 2 pi, and 2 pi will cancel out. So we have omega naught sigma naught into x cube by dx. Hence total current I will be equals to, here we see that x is the variable, so x is the represent the radius of a strip, so it will vary from 0 to r, because radius of this is given r. So 0 to r di, 0 to r omega naught sigma naught x cube ds, omega naught sigma naught 0 to r x cube dx. And solving this, we have omega naught sigma naught x4 by 4 0 to r limit, or omega naught sigma naught r4 by 4 ampere answer. This is the current constituted by rotating this